That's number 1. That's number 2. And that's number 3. So work on those 3. Yeah, just come on in, whatever. I don't know. We started at 8 o'clock this morning. This is our first 3 problems. We're just reviewing a little bit of what we did the other day before I go into trigonometric functions. You should have made this the in-class test today. Anyway, I have to give y'all an in-class test so y'all if your grades go down. I don't think we'll have an in-class test next week. It'll be just like this.
Really?
We'll probably have 5 questions. And you're supposed to fuss about how hard it is afterwards. Just make sure you do that. Tell all the teachers you got next semester that hard test. Why you passed. No. That's how they should be set up. Unless I made a mistake writing them down somewhere. It's gonna be kind of yucky. Gonna have to do some algebra on that first one. Not too much algebra on the second one, but a little bit. Third one's probably the easiest. But you can quit on number 1 if you wanted to. Encouragement is overrated. You gonna have volunteers come up and do it on board day? Yes, ma'am. Does anybody see where General Colin Powell's emails were hacked? Anybody see that on the news? It's funny. He's a Democrat, which he says that he's a Democrat. Funniest thing that he said several things that were funny, but funniest thing that he said, Hillary has the gift of destroying anything that she touches. But that ain't the funniest thing. The funniest thing is what he said about Bill. That was funny.
What was that?
It had something to do with him. Yeah, still at it. Yeah, still at it. That's a business partnership. Ain't worried about her. He had the charisma to take him to the White House, and she's still riding on that charisma. That's why he's out there campaigning for her, because she's not a campaigner. Oops. Let's see if I got an eraser today. Oh, I got my eraser. Let's see what happens to turn it off. The third minus 2b, negative 4b to the negative fifth, plus minus b 2b, 2b to the negative 3, and I'll change that to a negative. B to the negative 4 plus b to the negative 2, 3b squared minus 2. Oh yeah, we gotta do the FOIL method twice, so we're gonna run out of room there. 3x to the third plus 6, 2x plus 1, x squared plus x minus 2, 3x squared, I'll just cut these out. We'll go to 3 separate pages. If it'll let me. Watched The Conjuring 2 last night. Pretty good.
Theaters or on
Direct. I didn't either, but it's good. There's 2 or 3 spots in it that I spilled tea all over myself. It's pretty scary. They had a mean looking demon on there that looked like a nun. Whew. She was rough. Alright, so I'm going to go ahead and clean this up a little bit more because the calculus is done. B to the third minus 2b times negative 4b to the negative fifth minus 2b to the negative third plus b to the negative 4 plus b to the negative 2 times 3b squared minus 2. Let's just go ahead and draw this. And I want you to do it in your notes also, because this is the calculus. So I'm going to write everything out because I don't want to make a mistake up here. So v to the third times negative 4v to the negative fifth plus v to the third times negative 2v to the negative third plus negative 2v times negative 4v to the negative fifth plus negative 2v times negative 2v to the negative third. I need y'all to make sure I don't make a mistake, because see that negative third right there? I could have messed that up. That is a negative third, yeah. So that'll be negative 4 plus 3 minus 5, negative 2. Plus, and I'm not worried about the signs, I'll change the signs at the very end. Negative 2 times what? V to the third minus 3 is V to the 0. Plus negative 2 times negative 4 is 8. V to the 1. 1 minus 5 is what? Negative 4. Negative 2 times negative 2 is what? Negative, be a positive 4, and that's v to the first. 1 minus 3 is what? Negative 2. Now the good thing is, that's pretty simple. Bad thing is, that's just the first part. That's just this right here. So we got to move that over, and then we got to do this other part. So negative 4v to the negative 2 minus 2 plus 8v to the negative 4 plus 4v to the negative 2. And that's it. I mean, for that first part. So I'm going to put that first part right here. Now we're going to do the second part. So we're going to distribute, use the FOIL method. So that's going to be v, 1v to the negative 4 times 3v squared plus v to the negative 4 times negative 2 plus inside v to the negative 2 times 3v squared plus v to the negative 2 times negative 2. Negative 4v to the negative 2 minus 2 plus 8v to the negative 4 plus 4v to the negative 2 plus 1v, negative 4 plus 2 is negative 2 plus the minus 2v to the negative 4 be plus 3v to the 0 minus 2v to the negative 2. That's going to give me negative 4v to the negative 2 minus 2 plus 8v to the negative 4 plus 4v to the negative 2 plus v, 1v to the negative 2 minus 2v to the negative 4. Let's just find the right, plus 3 minus 2v to the negative 2. All right, clean it up. It could be where? Okay, everybody say on 3. Yeah, I was gonna say that. 1, 2, 3.
I was gonna say that.
Okay, everybody. 1, 2, 3. Okay, now that everybody said that, now let's look at it. Keeping people. Yeah, I was gonna say that. Yeah.
I swear I was thinking about it.
Where?
So the first on the right side.
Right here.
Yes. You got 3 times 1. Under that, you got 1 in each square.
Thank you.
Here you go.
Thank you. Yeah, I was gonna say, yeah. No, let me tell you something. Every class, every single class I teach, if I make a mistake, there's one person that's gonna point it out. And then right after that person says it, yeah, man, I'm gonna say, yeah. It's not just you. Every single class. No, it's just, oh.
Don't be like the bureaucrats who get.
No, I don't get offended by making a mistake. I make them. I ain't worried about that. Just everybody needs to say it one time. Okay? All right, now, this is a mess. Where? You talking about right here?
Yeah.
Product rule. Product rule. First times the derivative of second plus the second times the derivative of first. It's the quotient rule that has a minus symbol. Now, if it'll help you, what you might want to do is put some of this stuff in positive exponents. That might help you. I don't know if it'll help you or not. Because to me, it's still a mess. So you could put, let me get this down a little bit, since we're doing so much calculus here. They say I'm loud. Huh? Yeah. I get loud and I get complained about. Bush's fault. So maybe this might help. -4 over what? B squared minus 2 plus 8 over what? B to the 4th plus 4 over B squared plus 3 over B squared minus 2 over B to the 4th plus 3 minus 2 over B squared. Now, do we have common denominators? So put them all together. So I'm going to put all my B squareds together. -4 over B squared. There's that one. No, that's not one. I don't know why I still put that one. Plus 4 over B squared. Plus 3 over B squared. Any other B squareds? Well, oh, minus 2 over B squared. Eight over B to the 4th. Minus 2 over B to the 4th. Minus 2 plus what? And that's going to give me, what's -4 plus 4? 0. Plus 3 is 3. Minus 2 is what? 1 over B squared.
Take those out. 8 minus 2 is what? Over b to the 4th. And I'll do this one for you. 1. Aren't you glad you finally found out how to do all that calculus? Now, you notice something else I did during this whole problem. What'd you say? No, I didn't manipulate it. I mean, yeah, that's what I did at the beginning. To rewrite it. But what do you see about the way that I've done it? Everything's in what? Step by what? See, some of y'all, students, not y'all in here, but students, try to do all of that between the 2 blue lines in the notebook paper. And that's why you may not suck at algebra, but you may have a careless look. And if you got a careless mistake, guess what? You blew up the spaceship. You gotta be careful. You gotta do every single step. Okay? Now, yeah, there may be some Raymans in here that can go from here to here in 2 sentences. That's great. Go create a cure for cancer, okay? But the rest of us make mistakes, and we have to write everything out. Also, what happens when why did I do this right here? Why did I go from here to here? Why did I do that? Because some of y'all, when it comes to negatives, and I mean not here in this class, students in general, when it comes to negatives and negative exponents, what do y'all do? And I guarantee you, somebody in here, when we got to this step right here, he was like, oh my God, I don't know what to do. Change everything, get rid of those negative exponents, and something may click and say, oh, common denominator. Always do that. When you get yourself in a complicated spot with a math problem, because you see how long this problem is, get used to it. When you get yourself in a complicated problem, go back to the basics. Right here. Okay, that means a negative. I got to put that in the denominator and do that all the way through, and you come out with something that you can actually deal with. Capiche? You're supposed to say yes or no.
Yes, sir.
Thank you for the interaction. I appreciate that. It's nice to have interaction in a class. Makes the class go a whole lot better, don't y'all think?
Yes, sir.
Thank you. Oh, y'all suck. Y'all are so programmed. I know half of y'all are high school students. You're not used to talking in class, not used to interacting.
Some people will figure it out.
Huh? Yeah, maybe a couple of semesters, maybe you'll figure it out. But hey, y'all are learning something. I had 4 students this morning say they were learning something, so that must be good. All right, do this one. Finish it if you haven't yet. Yes, sir.
Is there a reason you get FOIL person from the
You could. Oh, where?
The last problem I just didn't know if there was something.
You could have done that. Good.
I did, and I got the same.
That's a great. That makes my day even. That makes it even better. Thank you. Yes, you could have folded at the beginning and avoided all of this. One of the reasons I did it that way, this way, is to show you how much of it's calculus. Very, very little. And plus, I didn't think. There we go. So, this one, of course, it's going to stay up there. Some frames it stays up there, some frames it goes away. Y'all figured it out yet? You'll figure it out in training. All right, so here we go. FOIL method. That'll be 3x to the third times 2x plus 3x to the third times 1 plus 6 times 2x plus 6 times 1 minus brackets. Do it again. Oh. I just decided to put a 3 in front of it. I'm sorry. Thank you. I have no idea where the 3x came from.
I was gonna say that.
Okay, you just failed the class, no matter what you do. Hold on a minute. I have no idea where that 3 came from. So let me erase it here. Let me erase it. Oh. I can't erase it there. I can mark it out there. Don't know where it came from. But thank you for not letting me go through the whole problem like the rest of y'all did. Appreciate it. All right, so this is going to be 3x squared times x squared plus 3x squared times x to the first minus 2 times 3x squared. All over the denominator. And as long as I haven't added any more numbers just out of the blue, this is going to be 2x to the what? 4th plus x to the third plus 12x plus 6 minus brackets 3x to the 4th plus 3x to the third minus 6x squared all over the denominator. 2x to the 4th plus x to the third plus 12x plus 6 minus 3x to the 4th minus 3x to the third plus 6x to the second all over the denominator. And 2x to the 4th minus 3x to the 4th is negative x to the 4th. If you don't add any numbers to it. X to the third, 1x to the third minus 3x to the third is negative 2x to the third plus 6x squared plus 12x plus 6 over the denominator. Okay. So again, the calculus right there. Most of your problems when you're dealing with calculus rules is 10% calculus, 20% calculus, 80 to 90% algebra.
Can you put back to where last one?
No, because I might have made another mistake.
No,
Hold
I
on.
just wanted to show that.
Mm-hmm. And the last one. Now, we haven't talked about e to the x because we haven't gone over logarithms yet, but it's kind of one of those things where the teacher's supposed to tell you the derivative of e to the x is e to the x, and you need to memorize it, even though we haven't went over logarithms yet. I think that's 3.6 or 7, somewhere in there. So, you need to remember to do that. Write that down. The derivative of e to the x is e to the x. Have I told you that before? I think I did, because they stick it in there and they say, oh yeah, you need to tell your students that, even though we haven't gone over derivatives yet. Derivatives, logarithms. So this one should be pretty simple. And you'll see a lot of e to the x show up in Calc 3 and Diff EQ. Why? because they don't want to bog you down with too many derivatives. So what they'll do is they'll do a problem and they'll throw e to the x in there so you can do the properties but not have to go through all the algebra. So in DiffEq you see a lot of e to the x's. And you can take the natural log of both sides, and when you take the natural log of e to the x, you get x. So in differential equations, you're going to see a lot of e to the x. So that's pretty much the calculus. Well, we got to do the calculus now. So 1 plus x squared times e to the x, well, I took the derivative, minus, parentheses, e to the x times, x, 2x, right, over 1 plus x squared, quantity squared, and that's, calculus is done. And so that's going to be e to the x plus e to the x, x squared, minus, parentheses, e to the x times 2x, and you could write that 2e, I'm going to change it in just a second, over the denominator, and that's going to be e to the x plus x squared e to the x minus 2x e to the x over the denominator. And what can you take out? You can take out an e to the x, and that's pretty much it, or you can leave it like this. 4 e to the x, and I'll leave you with 1 plus x squared minus 2x, and of course you put that in order. These two, any form of these two answers, either. So, as I said, the third one was what? The easiest, because e to the x, the derivative of e to the x is e to the x, and they'll throw that in there just to make things easy on you sometimes. Capiche? Okay, thanks for the interaction. So now remember, I'm not one to make you memorize stuff. I like for you to learn it, but sometimes you need to memorize stuff. And here's one of them. Didn't come out too good, but you get the gist of it. Well, I'll tell you what, hold on. Let me go back to my handy dandy online. Blow it up a little bit before I copy it. Now the reason you need to memorize this very well is because when you get to the integrals or the antiderivatives, you're going to get mixed up if you don't know them. Okay? And there will be times when you think you know it and you don't. Okay? Believe me, I know. And I'm just telling you, the more you memorize it, the better. So let me take this and do this and do that, do that. Now bring in the new one. There, that's a little bit better. Yeah, I'm glad we had training. Now the three that you're going to see, the two that you're going to see the most are cosine and sine. I'm going to go ahead and tell you that right now. Unless you're doing like number 57 out of 58 problems, most of the time you're just going to see sine and cosine. Number 57 will be like the secant or secant squared or whatever. But most of the time on a test or in a Calc 2 class or whatever, you might see Most of the time, you're gonna see sine and cosine, maybe sometimes tangent. The others, the reciprocals and the cofunctions, you don't see them as much. But anyway, derivative of sine is cosine, derivative of cosine is negative sine. That's something that needs to be in your head. Because when you get to antiderivatives, it's totally bass backwards. So you have to kind of keep one side, okay, and then you have to keep the other side, but you will get it mixed up. So just learn it the best way you can.
So what is d over dx?
The derivative. You could write it f of x is equal to sine of x, f prime of x is equal to cosine of x. Or y is equal to sine of x, y prime is equal to cosine of x. You could write it like that. Now, they're pretty simple, unless they throw the chain rule in. And that's where, if you don't know the chain rule, you're going to suck at trig, okay, as far as calculus goes. Because you can't forget the chain rule. Just go over the chain rule right quick. 3 times x minus 2. Let's make it 2x. 3 times 2x minus 2 to the fourth power. Okay, do that one by the chain rule right quick.
That sucks.
3 times 2x minus 2 to the fourth power. Of course, all of you done your chain rule homework, so you know how to do this, right?
Yeah. Yeah, I know how to do it.
4 times 3, 2x minus 2 to the third times 2. Now, before you start blurting out, where did 2 come from? Where did the 2 come from? Derivative of what? What's inside. That right there, take your notes right now. That's the derivative of what's inside. And that's what you got to remember. So if you're writing in your notes and you forgot, then you need to say d dx of what's inside. I usually do it over here, but when you do it over here and you've got numbers, it's going to come out front. So 8 times 3 is 24. So 24, 2x minus 2 to the third power. All right, that's the chain rule. Now, if I give you f of x is equal to, there's 2 types of trig derivative. One is just take the derivative. 4 sine of x. Okay? So f prime of x is going to be 4 what? Cosine of x. Those are the easy ones. But if you have 4 cosine 4 of x, then you got what? Chain. Then you got to distinguish between the two. Sometimes on a test, the teacher will put 4 cosine 4x, and y'all will put 4 sine of 4x, and then you will think it's right. Not because you don't know, it's just because you don't see it. So just remember, there's 2. That's the first type. And you can do those. You can do f prime of x, f of x is equal to secant of x, f prime of x is equal to secant tan. And you can put a 4 out there, put a 4 out there like that. I mean, those are straightforward. You're not going to have too many of those on the test. You might have 1 or 2, but they usually don't give those. They give the chain rule. Second type is it doesn't matter. Doesn't matter which way you go. There's no pattern to it.
Is there a descent?
I don't know. I just now learned how to group it. See, there's no pattern. There's no. You can't explode. You can group and ungroup. But there's no. Now, in the next problem, if I do this, it'll highlight it. But if it's in close proximity to this, it's going to highlight it. So, anyway, so let's go. I'm glad I had training. So, let's just write type 2. This is type 1. Type 2 would be f of x is equal to 4 cosine 4x. Do that one. Well, f prime of x is equal to negative 4 cosine of 4x times what? And that's what people forget to do. Take your handy dandy highlighter. And this 4 comes from what? The derivative of right there, because it's the derivative of what's inside. To make things easy on yourself, whenever you have a cosine of 4x or cosine of 2x or whatever, put parentheses around it so you can remember to take the derivative of what's inside. Because that's going to get you. Yes, sorry. Okay, thank you. Okay, everybody say it. There you go. Now you're getting it. Actually, I don't know why. I think I was more focused on doing those, but that happens too. But you need to make a note. Derivative of what? What's inside? Now, unless you get some math geek, that what's inside, you're going to hear that over and over and over with the chain rule. Anything pertaining to the chain rule, you're going to hear what's inside, what's inside, what's inside. What's inside of what? Well, that's why you put these parentheses. So your final answer is f prime of x is equal to negative 16 sine 4x.
How come you can't do it a negative or something?
That's another reason. You got to learn those. You got to learn those. So what happens is you get the following. I'm going to erase all this.
about 6-8 minutes to visit. Oh, forget it. I'll just start a new page and just bring it back in. Oh. But I refuse to have the technology in the classroom and not be able to use it, so I'll wait on IT. Oh, I don't know if y'all saw this, but Tri-County Tech's Tutoring Center is offering, have y'all seen that announcement? Tutoring online. Amazing. How long has Hubert been doing tutoring online? 2 years. But somebody, the click will get it, and it'll be, wow. Y'all don't know what a click is yet, but when you get in the job world, when you get in the real world, you'll find out what the click is. Just like in high school. The click. Not C-L-I-C-K. Okay? That's not it. You need to look it up. C-L-I-Q-U-E. I think that's right. All right, let's do, how about let's say f of x. I'm going to pull up some out of the homework while y'all are working on this one. Is equal to, I'm going to give you an easy one. 4 sine of 2x. I'm going to put that in parentheses for you. Brackets. Times 2 cosine of x. All right, work on that for a second. All right. So f prime of x is equal to, first, times the derivative of the second, 2 cosine of x prime, plus the second cosine of x, times the derivative of the first, and that's going to be 4 sine 2x prime. So f prime of x is equal to 4
sine 2x times the derivative of cosine, which is the negative sign, so that's going to be times negative 2 sine of x plus 2 cosine of x times 2, which is 8, right? I'm going to put it in parentheses. 8 cosine of 2x. And that's pretty much it. You could multiply the negative 2 and 4 and get f prime of x is equal to negative 8 sine of 2x times the sine of x plus 8 cosine of x times cosine of 2x. We'll do a couple more that will be a little bit easier to work on. That was just one I made up. I just wanted to see the product with the chain rule with trigonometric derivatives. I'm sorry, what? Yes, 2 times 8 is 16. Thank you. All right, now let me bring in a couple out of the book. Okay, that's 1 second. You said just a second. And the reason you know to use product rule is because multiplication. Now the biggest problem you have besides remembering the derivative rules, because there's 4 you know now. There's the basic rule, I meant 5. The basic rule of derivatives, power rule, product rule, the quotient rule, the chain rule, and the derivatives. But you've got to look at the problem and be able to know what to do. That's why I add things like these parentheses, because when you see those parentheses in a function, you know to use the chain rule. Well, I didn't use the chain rule with this. You didn't have to, because what's the derivative of x? 1, and 1 is multiplicative identity, so it doesn't change anything. So that's why you don't have to do the chain rule here. Go. Okay? But adding those parentheses and putting that big dot right there, hopefully tell you use the product rule with the chain rule with the trig identity, or not identities, the trig derivatives. Good? All right. Let's try nerd. Let's bring in the chart, or the jigger. Move it over. And bring in the clowns. Let's do this product rule first. I can try that one. They gave you an easy one in the book to do, so I guess I'll give you an easy one. Does Mr. Browning still teach physics every once in a while, or does he just substitute at Westside? Huh? He does teach? Oh, he did. He told me that I was going to be a janitor at Forest College. That's what he told me when I was a student. He's got a very dry personality. I don't even remember going to his class. It shows you how much I participated in physics. I guess not even. I don't even know how to comment. I don't.
I had physical science with Daniel Ford.
Mm-hmm. Who?
Daniel Ford. He's a Pokemon teacher.
Why are you taking physical science when you're in? I thought you were in engineering.
Right now I'm getting associates.
Oh, okay.
We
Yeah.
have fun. We're dropping balls from staircases.
Yeah, they say you do a little bit of biology and a little bit of chemistry and a little bit of physics. I think it's a good course if you suck at all three of those courses, you know, before you take them. That's what I would do. I shouldn't, oh gosh, I mean, I had real bad experiences with biology, chemistry, and physics. No, not physics. I was okay with physics. Y'all know where Oconee 323 is? It's at the end of the hallway in Oconee Hall. That used to be the chemistry lab back when the first rooms of Oconee Hall the first one was the first floor was English, the second floor was math, the third floor was science because it had the labs. And I was sitting over there near the window, and if you've ever been in Oconee 323, the window is across the room. And I decided I was going to throw a big paper ball across the room and throw it in the trash can, which was near the door. And this thing weighed about 2 or 3 pounds. This thing was huge. It was about like a volleyball, okay? I threw that thing across the room, and guess who walked in the door? The teacher. And it dinged him upside the head. So that was not a good first day. So that was my chemistry. He was chemistry. His name is Dr. Kling. K-L-I-N-G-H. Kling. Okay? 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 And that's all he said. Every word. Okay? Okay? Oh. So, x squared times sine, the derivative of sine is what? Cosine of x plus sine of x times 2x, and that's going to give you x squared cosine of x plus 2x sine of x. Okay, so that's your two types, but you can still throw a third type. And third type is one that calls those identities that you were supposed to learn back in Trig. Ooh. Is that one of those I suck at identities? Is that one of those moans?
Yes.
Okay. Well, then you're going to fail this class then.
Absolutely.
Yep. Drop.
Quick.
You can still drop. I think you can drop without a W. Something like that. All right. So bring in the third type of problem. And quit. First of all, I need to fix something. That would bother me. Of course, now it's not going to. Yeah. And I gotta make it bigger. And now I'll fix it. Y'all impressed me. I know you are. All right, so go ahead and try it. You're probably gonna quit, but go ahead and try it. No, I don't think so. Let me check right quick. I pulled it out of the book. It may be just another word. No, that's a period. We could make it something else if you want to. We can make it square the whole thing. Well, you tell me. What do you do? Well, it's division, so what do you use for division? Yeah, if that one person that mumbled, yeah. Yeah. I guess mumbling interaction will count. I have no idea who said that. So I'm not making fun of you if I don't know who said it. Huh? I guarantee you if I mumbled, y'all let me know about it, wouldn't you? Dr. Harden, how'd you do that? I can see that man right now. First semester calculus. I wonder if they got a picture of them on the internet. Bet they do. I got to take the roll anyway. Because y'all gonna start getting fidgety pretty soon. I'm Ed. Anderson and Anderson's here. Caldwell. Flint Skills is here. Cook. Here. Ricks. Here. Grant. Hernandez. Here. Huth. Here. Johnson. Here. Jordan. Here. Marshall. Marshall. Patel is here. Fan. Here. Scobie. Salee. Sheik is here. Silver. And Tucker. Let's see if Dr. Harden is on Google, even though he's dead. No. Yeah. Nope. 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 That's pretty bad. How old were you? I graduated in 95, so 94. So it probably 3 years or a couple of years before that. I bet his name, I can't remember his name though. Can't remember his first name. He didn't call him by their first name. Hold on a second, let me try math. Nope. I had one professor that sounded like Sean Connery when he talked. Huh? I don't know. I don't know. I want to say William Harden, but I don't know if that's him or not. But I don't see him. And he was well known up there, so I don't know why he's not on Google at least. But he's about 4'5". What? No. I don't know his first name though, but anyway, he's about 5'5". He's about this tall. I don't know how tall 5'5" is. He's short. And he got white hair. And then there was Dr. Ruckel. He taught advanced calculus 1 and 2. And he was about 6'3", weighed about 300 pounds, and he was obsessed with Tetris. At that time, Tetris was on, you could get it on your computer, and he would sit in his office all day and play Tetris. Is it Tetris or is it, which one is the blocks coming down? Yeah. Oh my gosh. And if you knocked on his door, he would have a heart attack because he was so into the game that you would scare him to death because his back was to the door. And he wore a polyester blue pants and a blue shirt, but he'd wear this big old Texas belt buckle. Another thing, math professor, and big old Texas belt buckle with a star in the middle of it. And he,
What are you doing?
he just, yeah, he would freak out. I can't believe he's not on Google. Oh well, what? What? Click the all tab. I had Dr. Lascar. Where? There he is. There he is. That's him. And he just grunt the whole time. And when he said a number, 2, 4, anything, 2x 4, 2x squared, you know how to do that, yeah. Then you could pull up Dr. Ruckel. Let's see if we could pull up Dr. Ruckel. 94, 95, somewhere in there. I don't keep up with dates. What? No. It was me. You don't see Dr. Ruckel anywhere, do you? I don't see him. What, here? Brawley, I had Dr. Brawley. I was trying to find Ruckel, see if he's, I don't see him. No. There's Dr. Lascar. Trying to find Dr. Ruckel. Yeah. He was interesting. I just go by there sometimes, just knock on the door just to see the job. Anyway. All right, let's do this problem so you can be discouraged. So, denominator times numerator prime minus the numerator times denominator prime over denominator squared. Derivative of secant is secant tan, so that'd be 1 plus tangent of x times secant tan. And if you ever notice, people, that's how they remember it, secant tan. They don't say secant of x times tangent, they say secant tan because it's easy to remember. Minus, which one are we going to take the derivative of? This one? Secant x times the derivative of the tangent is the, I lost it, where is it? There it is, secant squared. Secant squared x. All over 1 plus tangent x squared. All right, now work on the top. Distribute that secant tan. See what you get. And secant x, secant squared, what is that? Secant third. So work that out. I mean, make it smaller. Finish it out. So that's going to give you secant tan plus secant tan squared, right? Secant tan plus secant tan squared minus secant cube squared, or secant cube x. Now there's a rule that says you can rewrite this if you don't remember it, that this is secant x to the first power times secant x to the what? Second power. You can actually write it like that if you want to. And that would be secant x to the third power over 1 plus tangent x quantity squared. Now I already see the identity. Where's the identity? I see it. 2 steps down, but I see it. Where is it? Well, you secant what tangent? Secant squared minus secant tangent squared minus secant squared. Yeah, I see it. Factor out a secant. Secant. That's going to be tangent plus tangent what squared minus secant squared x, you see it? All over 1 plus tangent x squared. And finish it out. I want to let y'all finish it out for homework. Or finish it out before you start your homework. All right. Now, let's talk about what's left. We've gone over, basically, we finished the chain rule today, and we started trig. We're going to go over implicit differentiation next, which will be Monday or Tuesday, whenever y'all come back. Go over implicit differentiation. I'm going to spend a whole class on that. The reason is you're not going to see it again probably until differential equations. You might see a little bit of it in Calc 2 and a little bit in Calc 3, but you get hammered with it in different Q. So I want to make sure you have at least 3 or 4 pages of notes on implicit differentiation so you can refer back to it when you do differential equations. All right? And then related rates. I haven't figured out how I want to do related rates yet. I usually give it as a separate test. The reason why is I don't want anything interfering with you understanding the related rates, because that goes in your physics. And you need to be able to understand related rates, not just regurgitate. Because you actually have to think about a ladder falling, and it's falling at the same rate that this is going out. So if you got a ladder up against a wall and it slips, this rate is the same as that rate. And you got to think about stuff like that. So I don't want you worrying about the trigonometric functions and all that while you're trying to do the related rates. You see what I'm saying? I want you to focus on the related rates. So I might do that as a separate test. Okay? Who's got questions for me? Anybody got any questions? So right now you need to be working on, and I'll assign, after y'all leave, I'll assign the homework. I want you to work on your power rule, the 2 on product and quotient, the chain rule, and I'm going to assign Trig, and yeah, I'll assign Trig. So you need to be working on those 5 sections, okay? Y'all have a good day. Letting y'all out a little bit early today. Any questions, see me. I'll fill out drop slips if you need me to.